Hello and welcome to another MIDRC seminar. Today's talk is on navigating MIDRC's data and tools. I am Maryellen Giger. I'm the contact PI for MIDRC, and I'm very happy to have with us Dr. Hui Li, who is a research associate professor of radiology at the University of Chicago. He has been working on quantitative image analysis on medical images for more than 20 years. His research interests include risk assessment, diagnosis, prognosis, response to therapy, understanding the relationship between radiomics and genomics, and their future roles in precision medicine with both conventional and deep learning approaches. We also have with us Dr. Jordan Fuhrman, who is a staff scientist at the University of Chicago, where he also received his PhD. His work focuses on the application of machine learning techniques towards advancing computer-aided diagnosis of medical images. This includes handling large amounts of data, understanding a variety of classical and state-of-the-art techniques, and determining which method is the most appropriate for the problem at hand. While Hui and Jordan are AI developers in their own right and also helping with the tools, they are also MIDRC users, and so felt that this seminar would be focused from the viewpoint of the MIDRC user. Jordan, could I please have the first slide? Okay, next slide. So just a quick refresher in 2 minutes. This is coming from the Medical Imaging and Data Research Center, which was established in August 2020. We're funded by NIB and ARPA-H, and it's a partnership between APM, ACR, and RSNA, and it sits on the Gen3 platform at the University of Chicago. It's created, and next slide please, to yield 2 main aims: an open, scalable, curated discovery data commons at data.midrc.org. To date, we have released almost 200,000 imaging studies on our open data site. This represents over 80,000 patients. The other important aspect of MIDRC are the resources, and that's what we will be going through today. We have various tools, and you will be hearing about 4 of them. Next, please. So this gives you the typical overview of MIDRC, where we have 2 input portals through RSNA and ACR. We've taken in radiographs, CT, MRIs, ultrasound, and other images. Once they're de-identified during intake, they undergo curation and harmonization, and this is according to the MIDRC data model to enable cohort building. 80% of our data is open to the public, and another 20% is sequestered, and this is done using stratified sampling. One of the things you will be seeing as you go through these tools is these tools were developed to enable MIDRC, but now they have been generalized so that you as researchers can use them. Next slide, please. So now I pass it to Hui Li and Jordan Fuhrman, who will go through these tools as well as demonstrations.
Good afternoon, everyone. Today, I'm going to talk about open resources, tools, and algorithms on midrc.org with my colleague Jordan together. There are 2 types of tools developed by MIDRC researchers. One is a web-based tool, such as metrology decision tree and AI reliability tool. The other type is a downloadable tool, such as RAG tool and the stratified sampling tools, which can be downloaded through MIDRC public GitHub page. Next, please. We are monitoring the representativeness of the MIDRC data to ensure datasets are representative of populations based on, for example, variations in the physical imaging acquisition system or variations in the regions of data origin. For the development of ethical and trustworthy machine learning algorithms, let's account for and reduce data distribution errors. Next, please. This slide shows the MIDRC data representativeness over time. MIDRC data contributions are coming from 23 states across the US. image data in the pipeline starts from data contribution agreement to ingestion to curation and then to release on the Gene3 output photo. Next, please. This slide shows the MIDRC data representativeness over time. MIDRC data contribution are coming from 3 states and the reporting on patient populations at subgroup levels, and the measuring representativeness is needed for robust and relevant data for development of AI in medical imaging. Next. We compared the MIDRC data to US Census and the CDC COVID-19 positive case counts using Jensen-Shannon distance. The red figure shows the output for the Jensen-Shannon distance for the representativeness of our data across over time. Next, please. Now, it is now integrated in the MIDRC Reactor 2. Next, please. This is a user face for the MIDRC Reactor 2. The data information, the detailed information is at the bottom of this slide. Now I'm going to pass to Jordan for the live demo.
All right, thank you, Hui. So I'll share a few different pages, if you bear with me while I jump between these. I'll start by showing the MIDRC main website and how you can navigate to our tools from the home page. The main way is to just go to this resources tab where you can click either web-based tools or downloadable tools. And for some tools, specifically most of the downloadable ones, you can access through our GitHub through this icon. But I'll use the resources tab to first show the React tool. So this is a downloadable tool. If I click this first one, MIDRC React tool, it directly links to our GitHub repository and the MIDRC React repository itself. So at this repository, we have a lot of background information about the React tool and how you can use it to measure the representativeness of your data. Some background on the technology and information on how you can either customize files for your own use and download and use this tool yourself. For the sake of time, I've already downloaded and installed all the packages and everything for this tool. So let me go ahead and share that now. Okay. So here is the kind of first look of the React tool with some example files. So what we're looking at here is a comparison between the MIDRC data and the CDC data that we just talked about. So in the center here, we have a comparison of the, we show the Jensen-Shannon distance over time between August 2021 and October 2024 for comparing these two data sets. Specifically, we're looking at the attribute age at index, but you can change to other attributes, for example, ethnicity, sex, and race, and this will continuously, all of these figures will update based on what you select. We'll stick with age for now, just to look at the other plots. So in the top right, we can show the distribution of different categories within that attribute. So we're looking at the age category, can make it a little bit bigger, where all of the different colors represent different age brackets that are defined in kind of a backend file that you can customize for your own uses. And then if we want to instead look at the CDC age range, we can just click these boxes and it will change to show the CDC values for our comparison. Go back to the first one. And then additionally, we have this spider chart that shows kind of the snapshot at the endpoint of these of all the attributes of the Jensen-Shannon distance of all of the attributes, comparing the MIDRC and CDC files. So additionally, instead of just, we don't have to just compare different kind of data sets. We can also compare, for example, subsets or like a larger data set in a partition or something. So for example, we can compare two different zip codes or 3-digit zip codes from the MIDRC data set and see how they are either alike or different. and determine if that's, something of use or of note for our research and development purposes. I also want to note that the zip code values, some of these Jensen-Shannon distances weren't before. These are aggregate metrics that are available that kind of capture the total distance between the two distributions we're comparing. If you kind of account for all of the attributes instead of doing each one individually. And you can customize your kind of backend files to produce these metrics. Finally, I want to mention that all of these figures and things can be copied or saved if you want to use them for, putting them in your own PowerPoints, or, if you close any of these tools, you can reopen them with these doc widgets and just select them up here. So this is a nice flexible tool for evaluating your the representatives of your data. And yeah, I think that's all I have to say about this. So I'll toss it back to Hui.
Next, please. Yeah, the next tool I'm going to talk about is MIDRC decision tree. This is an interactive decision tree to assist MIDRC user in selecting metrics and reporting performance. It asks a user a series of questions to guide them through a decision tree for metric selection. Now it's incorporated into IBD's catalog of regulatory science tools. Now I'm going to pass back to Jordan for the live demo.
Sure. And as before, I will go back to the MIDRC homepage to show you how you can get to this tool. So going back to the homepage, we have resources. And this last time we did downloadable tools. This one is a web-based tool. Click web-based tools, and then we scroll down to the MIDRC metric tree. Click that. It takes us to this web-based application. You can see, welcome to the Medical Imaging and Resource Data or Resource Center Metrics and Resources portal. So to begin using this, we need some kind of development or research problem. So let's just pretend that we're interested in a cancer classification problem just between malignant and binary cancers. So we'll just click on classification. And since we're just doing malignant versus binary, we can do binary classification. You can see it nicely shows some examples of what might fit in that task. And then this shows the metric tree where you'll kind of walk through this tree based on kind of information about the project that you're interested in. And this might prompt, this is a really nice thing, not only to help you identify potential metrics for your research and development, but also to have you kind of think about what questions are relevant to develop or to designing your project. So we'll click here to begin stepping through the metric tree. So the first thing this asks is about the reference standards. So it says, does your reference standard or truth have negligible unreliability and variability? Since our toy case is for benign versus malignant cancer, let's pretend that we have biopsy truth. So we'll say negligible unreliability and variability. And then it asks, what is the type of output of your AI ML algorithm? So let's, again, instead we have binary or non-binary. Let's assume that we're predicting some probability, so a continuous value between 0 and 1. So this would be non-binary because it's a continuous variable. And now we see some examples of the kind of analysis that is relevant to this kind of task. So let's just go ahead and choose receiver operating characteristic or ROC analysis, which is quite common in the AI development and evaluation world. So when we choose that, we get some references and materials information relevant to that. For example, this gives a video created by Brandon Gallus at the FDA and gives some references and background information. And then additionally, we have more steps in the metric tree that can help us sort of get to those final final values and metrics that we want. So for example, I chose area under the ROC curve and plotting of the ROC of the entire curve. You can see after choosing that, it displays figures and gives examples of how the ROC curve and AUC would change for different distributions of cases. There are also nice it gives packages and references related or that can be useful for a user. So I think this kind of tool is especially something that I would have liked to have as a younger researcher, like getting into new projects. But even, at my current stage, if I were to begin a new project, this would be kind of the first place that I would start to think about, in development and evaluating my project, especially if it's not something that I'm familiar with. Okay, and I will send it back to Hui.
The next tool I'm going to talk about is the MIDRC AI Reliability Tool. The MIDRC AI Reliability Tool helps researchers fix and find and fix potential issues in AI and machine learning models used in medical imaging. It guides users in spotting sources of trouble and suggests ways to reduce them, leading to more accurate results. This tool promotes best practice for creating reliable AI machine learning system. I'm going to pass back to Jordan for the live demo.
Okay. So starting again at the midrc.org homepage, we can go to resources. This is also a web-based tool. If I scroll down to the MIDRC AI Reliability Tool and choose that, we have a nice introduction here that some MIDRC investigators have put together that shows this really complicated Venn diagram, shows how all the different kind of phases of an AI development process, and like all those different steps, and how different sources of systematic errors can exist in all of them and even be sort of parts of both of them. So to give you an example, let's suppose that I'm working on or I'm planning to start a new project, thinking about collecting some data for the project. So we'll choose data collection. We'll think about issues possible during data collection. So something that's been really popular in recent years is issues with the generation of synthetic data, especially with new models and new generative AI being produced. This is becoming much more common. So the MIDRC investigators have identified potential issues with this. There's a description and background of what synthetic data is, why it might be useful for you, and then give some real world examples of when synthetic data has potentially been cause a systematic error and how you can potentially mitigate these issues. And there are some references additionally that you can read into more. I also want to point out, for example, if we look at temporal data issues, that we note that for whatever we're looking at, temporal issues in this case may also occur during other phases of development. So we're in data collection right now, but temporal issues may be relevant in model development, model evaluation, and model deployment stages. And these colors correspond to the colors in the Venn diagram. Okay, and that I'll pass it back to Hui.
The next tool I'm going to talk about is the MIDRC stratified sampling tool. This tool is used to ensure the samples are representative of various subgroups within the dataset. It supports the development of more robust and generalizable models. We use the stratified sampling tool to divide MIDRC data into two columns. 80% are public available and can be used for model development, and 20% are in sequestered data. The stratified sampling tool can be used for sequestering, independent testing, and regulatory submissions. I'm going to pass back to Jordan for the live demo.
All right. Thank you. And for the final tool, we'll go back for the fourth time to the MIDRC homepage and look at resources. This stratified sampling tool is a downloadable tool. and we'll scroll all the way down. I do want to point out actually quickly while we're on this page how many different tools MIDRC has. We are only highlighting 4 today, but I encourage you all to check out some of the other tools that are available. So the generalized stratified sampling tool is on our GitHub. And again, there are instructions on how to download and run this tool. And again, for the sake of time, I've already done that step. So let me share the tool itself. Looks like this. And so I guess to give you a bit of background, the point of the stratified sampling tool is to divide your data set into different subsets that have matched variable distributions across those subsets for a selection of variables. So we're going to use a test data set of 5,000 cases that have this binary disease state. You can see each row corresponds to a case. Each column is a different attribute related to that case. So let's say that in our AI development process, we want to match age, disease state, ethnicity, race, and sex across different partitions. We can select those features. We have this dataset column name, which will essentially be a new data or a new column that we create that will you'll see in a second, but it will indicate which partition each case belongs to. And then here's where you decide how you want to split your data. We provide 2 kind of common approaches. First is 5-fold cross-validation, and the second is training and validation with an 80%, 20% split. You can choose whatever you want. You can change these values to match, the split that you prefer. And these values don't have to add up to 1 or 100 or anything. The back end of the code will kind of calculate that for you, or calculate how it needs to be normalized for you. So for example, I could do this. These will add to 120. That doesn't matter. It will calculate that for you, or calculate how it needs to be split. So for simplicity, let's just do training and validation to start. We do need to treat numeric and categorical columns separately, or differently. So we'll choose our numeric column. The only one in this data set is age. And we need to set bins related to how we want to kind of divide our age into different categories. So just for simplicity, we'll go with 0, 10, dividing our age into bins of 10, or width of 10. And you can change this as much as you want, as we did in the previous one. And then finally, we need to select the unique ID for each case, which in this case is this submitter ID column. Okay, and then now we can do our stratified sampling, which will take just a second, hopefully. Okay, and what we see are the different colors that correspond to the different data set, or to the data set column, which shows, for example, these first 3 in the training set, 4th is in the validation set, and that continues for our 80-20 split. And just for completeness, I'll change it to 5-fold cross-validation and show the same thing. And you can see these all say fold 1, 4, 1, 2, 3, 4, 5. There are some nice papers at the recent SPIE medical imaging meeting about the use of this tool by an undergraduate and a graduate student in our lab. So I encourage you all to check those out. And with that, I will toss it back to Maryellen to finish up our part.
Okay, next slide then. Okay, so I want to thank Hui and Jordan on going through these 4 tools: the React tool, the MIDRC tool, the MIDRC metric tool, the AI reliability tool, and the stratified sampling tool. Keep in mind these were built for MIDRC and now generalized so everyone can use them. And I thank them for giving that user perspective of how to approach these. If you're lost, just start at midrc.org. While we're here, I want to point out some of our outreach for you to learn more about MIDRC. We have these monthly seminars. They are all recorded. So if you miss one, you can find it on our website. And we have them all on our YouTube channel of MIDRC Media. Much of the software you've seen is on our open MIDRC GitHub, as well as demonstrated through publications and presentations. So if you ever need an update, go to midrc.org and look at MIDRC by the numbers. Next slide. I also want to note that, and no, next slide. Got it. Okay. Many of you may be submitting NIH grants, and it's important for you to share and manage your data according to the NIH DMS policy. MIDRC is here to help you do that and serve as a place to have your data. Next, please. So keep in mind with this sharing, it helps the sustainability of your research and also sustainability of MIDRC. Next, please. So I now thank you again, and we're all three of us. We can go on camera and answer any questions you have. If I look in the Q&A, one of the questions, two of them have already been answered, but are there any others? Because I have a few. I think it's useful to get an idea of how user-friendly these tools are. And we really push for that because once a method is developed, and it might be just in the developer's code, it needs to be converted to a tool. And once it's converted, we then let it loose to various members in the different labs and out there for you. And we always welcome your comments. Let's see, there's one here. Here's one. Would we have to submit our data, or would users be able to access data from other repos using an API? Well, today we've talked about tools, and you can use these tools on your own data, but I'll pass that one to Jordan. We are able, with MIDRC, you can use APIs and access MIDRC data. Others, it will depend on the data commons, but I'll leave that to Jordan if he wants to broaden that.
Sure. I know there are some. I'm not entirely sure I understand the question, but what do you have to submit?
It's under the Q&A. So would we have to submit our data? Well, if it's a web-based, you put your data in,
Yeah,
because you want to use a tool on your data.
Yeah, to use these tools, you don't need to submit data. You can, I mean, you could download, for example, the data.midrc.org website has like table, or you can download a table that gives kind of all of the metadata characteristics and such. And you can use those for example, the React tool and the stratified sampling tool can both kind of take that table as input, and you can do evaluations on that. And for all of these tools, you're not uploading anything. They're run at this point. Well, for the React tool and stratified sampling tool, they're run locally. But for the other tools, I mean, they're web tools that you just kind of click through. So I don't think they have any restrictions like that. But as for the usability that Maryellen mentioned earlier, those two tools are very accessible, and you can just go and click through to your heart's content.
Thank you. And then another one is on how to find other researchers to collaborate with. First, I want to point out any of you can download and use these tools. These tools are there for all investigators to use with or without collaborating with others, with or without collaborating with MIDRC. They're there for the medical imaging AI community. Let me see if there's more questions. Let's see. Someone asked, I work for a repository and
This
would
is a
like
follow-up
these.
on the previous question.
Yes.
I guess I'm still not entirely seeing. I'm not understanding why you wouldn't be able to just use the web-based the two web-based tools through the MIDRC website. For the other ones, you can use them. You have to download. But for the first two, or the two web-based tools, the metric tree and the AI reliability tool, you can access both of those through MIDRC's website, and you don't need to contribute data or anything for that. For the others, you can download them through our GitHub repository.
Right.
And then the other question about how much curation is needed on these data. Hui, do you want to take that? Or would you like me to? I can also answer that.
Probably Maryellen may be the best answer for that.
Well,
Okay.
go ahead.
Do
We
you,
didn't
do
talk. Go ahead, Jordan.
well, I guess are you
We all
asking
can
if the question's about curation of like the metadata, for example, prior to use in the stratified sampling or React tools, there is depending on how your data is organized, you may need to do some reorganization. The for example, I showed that table that I showed during the, which actually maybe I can just pull it up again. This metadata table is essentially exactly the input for format for the generalized stratified sampling tool. So any like Excel or CSV file that fits kind of, has attributes and columns and cases and rows works for this, and the same for the React tool should work for that as well.
And anyone using these tools, please feel free to send us feedback.
Yeah.
We pass it through many users to guess. We want it working well, but also user friendly. And we are very much open to comment. I can leave a question to. Oh wait, there's another one. They keep popping up.
Maybe
Any
I
plan
just,
to publish these tools as Shiny apps or on Python anywhere? Well, we do that. Go ahead, either one of you. They are Python in the GitHub.
Yeah, you can download these through the GitHub repository. They're not published currently on, any other reference, but I think that may be in the future, but we'll see.
Yeah, I also note that when you go to midrc.org and you look at these tools, often we have published work on the tools, and those are all there. They're in the resource page that we showed you, as well as the GitHub page. If there's an associated MIDRC publication, you'll find that there also. And then our GitHub is public. Let's see. There's also a question, curious how hard it is to submit these data types into MIDRC. Well, we're constantly intaking image data from medical institutions and others. We take in DICOM medical images with some metadata. If you have data that you would like to contribute, please go to midrc.org, and there is I can bring it up potentially. Let's see, if we go to midrc.org, and let me share the screen. Oh, you did it already. Oh, you did it. Great. No,
where's
no
the
problem.
contributions?
So
I don't
the
actually
contribution of data page that is under data. Yeah, thank you. The other questions. So I'll ask a question to Quay, and then Jordan is, you've used some of these in your research. How user-friendly? We even have like summer students using them. Maybe if you want to give a user perspective on the ease and the back and forth feedback.
Yep, I can jump in a little bit. So I personally use, and if you go to the metric, the .arg and the README file and the instruction are very clear, and then you just follow the instruction to download, and then it's very easy to use.
Yeah, and I've used especially the stratified sampling and React tools in my own work. It's like I said, most of the input files are things that I already have. I would suspect most people have some kind of table with like case IDs and all the attributes that are kind of relevant. So that's all you really need for at least those two tools, and then the other two web-based tools. I've clicked through them to my own just to learn a little bit. I haven't used them yet for my research, but I think they're web tools that you can click through. They're extremely easy to use.
Yeah, I just want to add, so for the downloadable tool, because if you look at the instruction, we also have the example data set. So it's easy, you can just, follow the example data set to format your data if, that's easy for you. So.
Right. Let's see, another Q&A popped up. No problem with asking questions. Do you have a suggested single paper that comprehensively covers MIDRC ingestion standards, which I should read? There's a lot of papers on that site. Well, the overview paper is in progress. I would say 80% done, has to be passed to co-authors and others. But a lot of these do have specific, if you have a particular area that you have a question on, say stratified sampling, there we can give you those articles. You can always email us directly. And we're happy you're eager to learn. And I would point out, especially with the MIDRC web-based tools, when you have students, summer students even, send them there to learn. They can learn about how to evaluate AI. What are some of the errors that might occur when developing AI? How to be careful with your data. So there's lots for learning here. Okay, and then there's one more. Nope, we answered that online. And I think, and also I refer you to the chat. Emily's been putting a lot in the chat on where you can go to on the website also. Anything else? Oh, we might be good to go. If last chance for questions. Again, this has been a how-to session. Please try these and give us your feedback. I'd like to thank my co-presenters, Hui Li and Jordan, but not so fast. We just got 2 more questions. Oh, yes. And we only covered 4 tools because we have limited time in these seminars. But we have a lot more tools, as you saw them fly by when Jordan went to the resource page. And we do the harmonization for the DICOM using LOINC based on the Red Left playbook. That is up on the GitHub. You have data, you want to harmonize it, use that. So thank you, person with the Ryan, for putting that in the questions. All right. One more question. Let me see this one. Oh, well, started writing, do you have another? But I don't know if you didn't finish this question. So Ryan, feel free to email us too, if you have a lot more questions. No problem. We're happy to see an eager person there. So we'll sign off. Thank you very much. And please give us your feedback. Thank you. Goodbye.